Welcome to our video tutorial on back to basic physics concepts. This time, focusing on a free fall problem. So just hang on, watch and learn. The given question is, from the top of a tall building, you throw one ball straight up with speed v0 and one ball straight down with speed v0. Question letter A, which ball has the greater speed when it reaches the ground? Letter B, which ball gets to the ground first? Letter C, which ball has a greater displacement when it reaches the ground? And letter D, which ball has traveled the greater distance when it hits the ground? Neglect the effect of air resistance. The correct answers to the four questions are, for question letter A, which ball has the greater speed when it reaches the ground? The correct answer is they will both have the same speed. For question letter B, which ball gets to the ground first? The answer is ball 2, or the ball thrown straight downward. For question letter C, which ball has the greater displacement when it reaches the ground? The correct answer is both will have the same displacement. And for question letter D, which ball travels the greater distance when it hits the ground? The correct answer, of course, is ball 1. For our solutions and explanations, we assume that air resistance is negligible, and we will let the initial speed v0 of each ball equal to 5.0 meter per second. And the height of the building, okay, is equal to 40 meters. And that the acceleration due to gravity is equal to negative 9.8 meters per second squared. To prove our answer to question letter A, that ball 1 and ball 2, upon reaching the ground, will in fact have the same final speed. Alright? We can do this by finding the final speeds of ball 1 and ball 2 when they hit the ground. And the formula we will be using is a kinematics formula where the final velocity v is just equal to the square root of the square of the initial velocity v0 plus 2gy. Right? So here we will be treating these quantities as vector quantities. And for ball 1, all right, its initial velocity is positive 5.0 meters per second when it is thrown straight up. All right, then plus 2 multiplied to the value of acceleration due to gravity, which is negative 9.8 meters per second squared, and the displacement y, which is in fact negative 40 meters. Why is this negative? It is because when ball 1 reaches the ground, okay, it is located, all right, it's located 40 meters below the reference level, which is the top of the building. All right, that is the displacement of ball number 1. All right, So when we do our math, okay, first doing the operation inside the radical sign, we in fact get square root of 809. All right, 809 meters squared per second squared. And the result of that, okay, with the help of your calculator, actually, that means that there will be two roots, a positive value and a negative value. That is positive and negative 28 meters per second. All right. Now, in as much as the question is only asking us to describe its final speed, so its velocity final is actually negative 28 meters per second, negative because it is directed downwards. But for speed, all right, since speed is a scalar quantity, there is no need to indicate the negative sign. So our final answer, therefore, is just 28 meters per second for the speed of ball 1. Okay, now how about ball 2? So for ball 2, we can also use the same formula, all right? The same formula, but when we substitute the given, okay, the initial velocity of ball 2 is in fact negative because ball 2 uh, is thrown directly downwards. Therefore, its initial velocity v naught has a negative sign. However, if that will be squared, okay, eventually it will still be a positive number, all right? Positive 25 meters squared per second squared. And then we add uh, 2gy, or 2 multiplied by negative 9.8, and the same displacement, negative 40 meters. And simplifying further, we will get an answer for uh, the velocity of ball 2, all right? Just like for ball number 1, okay, it has a negative sign, okay, because it is also directed downward. But since we are only considering the magnitude of the velocity, which is the speed, it is 28 meters per second. All right? So both balls 1 and 2, in fact, have the same final speed, okay, when they reach the ground. And this supports our answer for question letter A, that the two balls, in fact, will have the same final speed when they hit the ground. All right, the answer that we have for question letter B, which ball gets to the ground first, we said that it is ball number 2. All right? Common sense will tell us that ball 2, the one that is directly thrown downward, okay, will reach the ground at a shorter time. All right? Whereas ball number 1, okay, the ball that's initially thrown vertically up will still have to travel upward, all right, as shown in this sketch. Now, when ball 1 reaches the maximum height, all right, it comes back and passes the same level as when it was thrown out, all right. So at this point, the instantaneous velocity of ball number 1 will just be the same, okay, as the initial velocity of ball 2, which is v naught, but directed downward, all right? And that explains why earlier in calculating for the final velocity of each ball, we got the same answer. All right? Because whatever is uh, the motion of ball 2, okay, from the moment it was thrown from the top of the building until it hits the ground, that will still be the same kind of motion that ball 1 will be having, all right? As it passes this level of reference and continues to uh, fall straight down, it will just follow the same kind of motion, all right? That is, it is uniformly accelerated, but with an initial velocity v naught, all right, that is directed downward. Hence, we were able to get the same final velocity for the two balls, ball 1 and ball 2. All right? So, although it is rather obvious that ball 2 reaches the ground first, we'll show how its time of reaching the ground, all right, or why the time of reaching the ground for ball 1 is longer than the time it takes for ball 2 to reach the ground. And the formula that we will use, all right, is simply the formula, uh, all right, the formula t is equal to final velocity minus the initial v naught divided by g. And in the case of ball 2, this is how we do it, all right? We substitute the given, the final velocity as earlier determined, all right, it's negative 28 meters per second, all right? Then minus the initial velocity of ball 2, which is negative 5.0 meters per second. So minus, we have a double minus sign here, okay? Negative 28 meters per second minus negative 5.0 meter per second, all right? That becomes simply plus, all right? Because of the double negative. And then divided by negative 9.8 meter per second squared. Doing our math, we will get the time t equal to 2.3 seconds. So this is the time it takes for ball 2 to reach the ground, okay, when it was thrown vertically downward with an initial velocity of negative 5.0 meters per second. All right? Now, how about for ball number 1? Okay, for ball number 1, using the same formula, all right? This time, um, the initial velocity of ball 1, okay, has a positive sign because it was initially thrown straight up, all right? But since we are subtracting negative 28 meter per second minus positive 5.0 meter per second, so the operation is still a minus sign or a subtraction, all right? And then that will still be divided by negative 9.8 meter per second squared. So doing our math, we will get the value for the time t, all right? The time t for the first ball or ball number 1 to reach the ground, and that is equal to 3.4 seconds. All right? So this supports our answer to question letter B, that it is ball 2 that will get or that will reach the ground first. All right? 2.3 seconds is much shorter compared to that of ball number 1, 3.4 seconds. Our answer to question letter C was that relative to the top of the building, which is our reference point, okay, the two balls have equal displacement. That is y equals negative 40 meters. All right? How do we explain this? If you look at the sketch, all right, our reference is understood to be the top of the building. All right? So when ball 1 or ball 2, all right, when ball 2 was directly thrown downward, okay, and reaches the ground, okay, what is the change in its position? All right, the change in its position is called the displacement. All right, and the magnitude of that displacement is simply equal to the height of the building. All right, which is 40 meters. And since the ground is below the reference, we put here a negative sign. And we say that the displacement of ball number 2, all right, the one that was initially thrown directly downward, its displacement is negative 40 meters or 40 meters below the top of the building. Now, how about for ball number 1? Ball number 1, which was initially thrown directly upward, okay, as shown in the sketch again, ball 1 still has to go up, reaches a maximum height, then it falls back to the same level and continues to go down until it touches the ground. All right? So, the actual path taken by ball 1 refers to the total distance traveled by ball 1. But that's not the same as total displacement. All right? So, just like ball 2, we ask the question, okay, upon reaching the ground, where is ball number 1 relative or with respect to the reference, which is the top of the building? Isn't it that the answer is also the same as negative 40 meters? Or we say that ball number 1, upon reaching the ground, is in fact 40 meters below the top of the building. So, ball 1 and ball 2 actually have the same displacement, okay, upon reaching the ground. That is equal to negative 40 meters. Okay. For the last question, question letter D, which was asking for the total distance, all right, or which ball traveled the greater distance, okay, upon reaching the ground. And our answer was that uh, it is ball number 1, because obviously, okay, its total distance, okay, is the sum of its distance when it moves up, then when it comes back to the same level, and the distance that we'll have to take in going straight down to the ground. All right? But since we already know uh, how far is the ground from the top of the building, which is just the height of the building, so we are just interested in knowing how high ball 1 was able to reach before it comes to rest and eventually comes back. All right? So we are only considering the upward motion of ball 1. And we can determine that height using the formula. The formula is d1, which is the distance of the upward motion, equal to the square of the final speed or velocity, which in this case is equal to 0. All right? At its maximum height, the instantaneous velocity or speed of ball 1 is in fact equal to 0. And then minus the square of the initial velocity, then divide by 2g. Right? So when you substitute, okay, um, The value of V naught is equal to 5.0 meter per second, but that has to be squared. But you should not include, or we should not put the negative sign or the minus sign inside the parentheses. Otherwise, you might think that the result of squaring this value will be a positive uh, value. Okay, it's supposed to be outside the parentheses. Okay, because that is the result of 0 minus the square of V naught. All right, and then divide the whole thing by twice the value of G, which is negative 9.8 meter per second squared. And when we do our math, we will get the value for D1 equal to 1.3 meters. All right? So, how it came out to be positive is because we have a negative sign for the square of V naught, or negative 25.0 meters squared per second squared, then divided by negative 19.6 meter per second squared. So we will get D1 equal to a positive number, and that is 1.3 meters. All right? So this 1.3 meters refers to the distance traveled by ball 1 in moving up to the maximum height. All right? But since it still has to go down, all right, from the top, moves down to the same level, so we just multiply that 1.3 meter by 2. All right? And the product, which is 2.6 meters, refers to the distance that ball 1 travels in moving up and in coming back to the same level. Okay, the same level as the top of the building. And then add to that, okay, the height of the building represented by D2, which is 40 meters. So we get the final answer for the total distance traveled by ball 1 equal to 43 meters. All right? That's the distance traveled by ball 1 in going up to the maximum height, okay, and in coming back to the same level and falling directly to the ground, 43 meters. And that's, of course, greater than the distance traveled by ball number 2. Ball number 2's distance traveled is just equal to the height of the building, which is 40 meters. That's why our answer to letter D, okay, is supported by our calculation for the two distances. All right? So that completes our answers to this question. Until the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.